Welcome back to our channel. Today, we're diving into a revolutionary breakthrough that could reshape the future as we know it: quantum computing. If you thought digital computers changed the world, quantum computers are about to take it to the next level. Quantum computing isn't coming, it's already here. In 2019, Google's Sycamore chip solved a problem in minutes that would take traditional supercomputers 10,000 years. That wasn't just impressive, it was historic. You might have brushed off the term quantum computing as something futuristic or niche. But the truth is, it's already starting to reshape industries like healthcare, cybersecurity, finance, and artificial intelligence. So what makes quantum computing so powerful? Traditional computers use bits, ones or zeros. But quantum computers use qubits, which can be both 1 and 0 at the same time, thanks to a principle called superposition. It's like flipping a coin and having it be both heads and tails at once until you look. Quantum computers also use entanglement, a strange link between qubits where the state of one affects the other, no matter how far apart they are. Einstein called it spooky action at a distance. This interconnectedness allows quantum computers to solve complex problems that classical systems can't touch. And here's the thing, this isn't just theoretical anymore. Recent breakthroughs have shown that scaling up qubits doesn't just add power, it helps reduce error. And although error correction has been one of the biggest challenges, researchers are making huge strides. This technology is advancing fast, and the global race to master it is heating up. In fact, many believe that whoever leads in quantum computing will also lead in economic, military, and cyber power in the decades to come. So, where will we see the biggest impact first? Cybersecurity is a major one. Today's encryption depends on math problems that are hard for classical computers to solve, but quantum computers could break them fast. That's why governments and tech companies are already developing quantum-resistant encryption, a whole new era of digital defense. Healthcare stands to gain massively too. Quantum simulations could accelerate drug discovery by accurately modeling molecular interactions. That means faster development of treatments for complex diseases, not overnight cures, but a major leap forward. Finance is another area watching closely. Quantum algorithms could process massive datasets for faster and more accurate market analysis, risk assessment, and fraud detection. Artificial intelligence could also evolve dramatically. Training today's AI models takes weeks, but quantum computers could cut that time drastically, leading to more advanced, efficient, and accurate AI systems. And then there's energy and material science. Quantum simulations could help design new materials and improve battery technology before they're even physically built, pushing forward renewable energy and sustainability efforts. Even climate modeling, which currently requires vast computing power, could be enhanced by quantum systems, giving us better tools to predict and respond to environmental changes. But it's not just industries jumping in, entire nations are battling for dominance in the new space race of quantum tech. The US leads with companies like Google, IBM, and Microsoft. Google's Sycamore chip demonstrated quantum supremacy in 2019. IBM is mapping out commercially viable systems by the early 2030s. China is moving fast too. Its scientists have built cutting-edge quantum communication networks and even launched a quantum satellite, a major leap in secure communication. Australia is investing $1 billion into its first quantum computer, while Quebec, Canada is becoming a hub for startups. This global race isn't just about computing power, it's about who will control the future's most powerful tool. Quantum supremacy: the moment when quantum computers outperform the best classical supercomputers could shift global power. Whoever gets there first wins. More than just bragging rights, they gain a real strategic edge. But there are challenges. Quantum computers are delicate and need extreme conditions, like near absolute zero temperatures, to function. Qubits are unstable and error-prone. Scaling is hard, and building these systems is expensive. Even when the hardware works, we still need software, real-world applications that make it all useful. That's coming, but it takes time. Still, progress is accelerating. Hybrid models using both classical and quantum systems are already being tested. These early steps will lead to wider adoption in finance, logistics, and pharmaceuticals over the next decade. Big tech companies are already forming partnerships with universities and startups to get ahead of the curve. Quantum cloud platforms are starting to appear, offering early access to researchers and developers. The groundwork is being laid right now. The bottom line: quantum computing isn't science fiction anymore. It's the beginning of a major shift that could impact everything from your bank account to your doctor's office. The ripple effects will be massive. And like any wave of disruption, the key is understanding it early. The people, businesses, and governments that adapt first will lead the way, and the rest will be playing catch up. Staying informed is no longer optional. The future belongs to those who understand how this tech will change the world. Thanks for watching. If you found this video helpful, make sure to like, share, and subscribe to our channel. Drop your thoughts in the comments. We'd love to hear what you think about the future of quantum computing. And don't forget to check out the next recommended video on your screen. See you in the next one.